Hello everyone, welcome to the lecture of IC engine fuel and lubricants. Today we will discuss the performance parameters of any engine, then basic measurements, blow by measurement, how the testing of SI and CI engine is done. We will see in this content we will see that, and we will do a numerical problem on testing and performance. So, the topic is performance parameters. We all know that what is performance. Any engine, you know that any engine is identified by its performance. We give energy in the form of input and we found some output and emissions from the engine. Because you know that what is engine? Engine is a prime mover which convert input form of energy into output form. So, input form of energy is taken from the fuel as chemical energy. So, we convert the chemical energy into the useful form. So, how we will predict the performance of any engine? That engine may be SI engine, that engine may be CI engine. So, generally we use these terms. We have already discussed these parameters also, but not in detail. So, in this lecture we will try to discuss these terms and elaborate these terms. So, first term is very important, indicated power. You can see through this diagram that this is a cylinder, piston, connecting rod, and this is crankshaft. So, we got brake power from either SI or a CI engine. So, what happened here, the combustion takes place, fuel burned here inside the cylinder, between cylinder and piston, and what happened, because the fuel is burned. So, the suppose 100% fuel is burned. So, we cannot convert it, the 100% fuel energy into the useful form. We are able to convert a small amount, 30 to 40% we can convert into the useful form. Remaining 60%, 70% goes into some other directions. These directions are what happened, you know that when fuel burned, we got some expansion. With the help of the expansion, this piston is moves, and the reciprocating motion in case of reciprocating engine is converted into the rotary motion, and we finally convert into the brake power. So, what happened if we burn the fuel? So, what happened, many amount of the fuel goes into the wastage, like in cooling of the cooling of engine. So, some amount of heat energy goes into the cooling water or some other means. So, it goes, it is waste, but it is needed. We cannot make it 0. Why we need cooling? So, that the temperature, metallurgical condition of cylinder, piston, and all the components of engine remain in the limit. That is why we need some cooling of the engine, otherwise there will be thermal stresses in the engine, and engine will get damaged or it will fail, it will not complete its life. So, it is some part of energy from the fuel is going to the cooling of the engine. Some, you know that from engine there are emissions, and these emissions have some gases, CO, CO2, NOx, sulfur dioxide, some oxygen, some hydrocarbons. So, they are emitted into the surrounding at higher temperature. Let surrounding temperature is 25 degree Celsius and the exhaust temperature is very high, 70 degree Celsius or maybe above it. So, because of this 70 and this ambient temperature difference, there is energy is lost to the surrounding, that is called exhaust, energy lost in the exhaust. So, exhaust loss is there, some radiation losses are also there. and useful work is only the brake power, and some energy also lost in the friction between the mating parts of the engine also. So, first of all, indicated power. What is indicated power? Indicated power is net fuel energy used to push the piston at this end. Power obtained at this end is known as indicated power. Now, come to the brake power. Brake power is 2 pi n t by 60, where n is the RPM of the engine and t is torque developed at the shaft end. Mechanical efficiency is the ratio of brake power upon indicated power. Volumetric efficiency is air actually sucked at ambient condition upon swept volume of the engine, because we know that when piston moves, like this is TDC and this is BDC. So, piston moves in this direction, the fuel is sucked and the fuel outside the cylinder is at ambient condition, at certain temperature, certain pressure, certain humidity level. So, when it swept from this point to this point, it is inhaled by the cylinder. So, it is not necessary that the swept volume is equal to the air sucked, because that depend upon many parameters, humidity, temperature, outside pressure also. So, that is that part, air actually sucked at ambient condition upon swept volume of the engine. It cannot be 100%, but it is desirable, it should be 100%, but it cannot be 100%. Now, indicated thermal efficiency. Indicated thermal efficiency is the indicated power upon mass of fuel burn per unit time into its calorific value. Calorific value is lower calorific, we will take here lower calorific value. Then brake thermal efficiency. Brake thermal efficiency is brake power upon mass of fuel burned per unit time into its calorific value. Similarly, indicated specific fuel consumption is fuel consumed to convert 1 kilowatt of power. So, how much fuel is burned? To convert 1 kilowatt of indicated power is known as indicated specific fuel consumption, and it is formulated as m dot f upon indicated power. Now, brake specific fuel consumption. Brake specific fuel consumption is simple, mass of fuel burn per unit time to impart 1 kilowatt of brake power. Now, mean effective pressure, we have already discussed this mean effective pressure. It is average pressure throughout the cycle, and it is measured as mean effective pressure is net work of the cycle, output of the cycle upon swept volume. It is measured with the help of indicator diagram. Indicator diagram is nothing but only the representation of pressure versus volume, or pressure versus crank angle rotation diagram. So, mean effective pressure can be measured from the indicator diagram as net area of the indicator diagram upon length of indicator diagram into the spring constant. Now, the fuel air ratio. Fuel air ratio is maybe of 3 types. It is rich, it may be stoichiometric, it may be lean also. Rich means more fuel, stoichiometric or means chemically correct fuel air mixture, and lean mixture means less fuel as compared to air. So, it is formulated by a term called equivalence ratio, which is actual fuel air ratio actual upon fuel air ratio theoretical. So, it is a very important parameter. With the help of it, we can predict that the fuel air ratio used, either it is rich, stoichiometric or lean. If the value of phi is equal to 1, it means it is stoichiometric. If phi is greater than 1, it means rich mixture, and if phi is less than 1, it means it is lean mixture. These are the measurements, because the parameters which I have discussed in last slides cannot be measured direct. We need some devices to predict these values, like speed or engine RPM, because we have to, if you want to measure brake power, you cannot measure directly. There is no instrument that you can measure brake power directly. You need, because the formula brake power is 2 pi nt by 60. So, you need RPM and you need torque. So, the RPM is measured with the help of tachometer. It is nowadays it is available in digital form also, digital or mechanical form. Fuel, then come to the fuel consumption, because engine always consume fuel, and at the same time it consumes air fuel mixture, because to run engine we need air and fuel. So, you should know what amount of the fuel is consumed per unit time by the engine and what amount of air is consumed by the engine. So, the fuel is measured with the help of fuel consumption device, measurement devices. These are of two types, volumetric and gravimetric. Volumetric means they are measured in terms of volumes, means with the help of stopwatch, with the help of some manometers, you can consume, you can evaluate the how much fuel is how much time is consumed to measure a relative amount of the fuel. With the help of this diagram you can understand that, this is a manometer and this amount of fuel is consumed in how much time. So, with the help of a stopwatch you will measure the time to consume this much amount of height of the fuel to consume in the engine. So, it is volumetric type or maybe gravimetric. The gravimetric means mass basis. Now, the air consumption is measured with the help of air box method, and second method is viscous flow air meter. Air box method is used. This is the example of air box method. Here this is the tank, it is having a volume of 500 to 600 times the swept volume of the engine because engine is running at a very high RPM. So, when it is running at very high RPM, there will be some pulsation in the movement of the air. So, this pulsation is damped with the help of using a very large size tank. This is orifice, air is sucked from here, and here the air in the tank is somewhat come into the static condition. That is why we use a large size of the tank. And similarly, with the help of manometer we measure the pressure difference across the orifice meter in terms of delta H. Delta H is the pressure rise or pressure drop in the manometer. So, viscous flow air meter is also gives you the same thing, but if the pulsation is very high, under very high pulsation, if we need accurate evaluation of the air consumption, then we use this air if the pulsation is very high. So, generally we use air box method, and this with the help of this theoretical mass flow rate is evaluated with the help of volume sucked through the orifice into density of air. This volume sucked is can be, this is rho A, written like this. A is the area of orifice and under 2 G, HW is the height of water manding. If water is here, water manometer is here. So, rho W is the water density, rho A is the density of air which is sucked by the engine into rho A. So, finally, the formula, theoretical formula, mass flow rate of air is A under 2 G H W rho W A W. So, actually the actual formula is, if we multiply this equation by coefficient of discharge. So, the actual mass flow rate is equal to C D A under 2 G H W rho W into rho A, where rho W is the water density 10 to the power 3 kg per meter cube. So, with the help of this we can measure the air supply to the engine. Similarly, the brake power is measured with the help of dynamometer. Dynamometer may be of hydronic, may be of eddy current type. With the help of it, dynamometer we can measure torque. Indicated power with the help of indicator diagram, and second method is, because we know that indicated power is equal to brake power minus plus friction power. Then friction power is measured with the help of this Williams line method, Moore's test and motoring test. Moore's test is used for multi-cylinder type of engine, multi-cylinder. So, with the help of these methods we can use friction power also. And second method is difference between IP and BP. You measure IP from indicator diagram, you measure brake power, you can measure brake power with the help of brake dynamometer. So, difference between IP and BP is known as friction power. Now, the heat carried away by the cooling water, it is mass flow rate of cooling water into its specific heat into temperature output of cooling water and temperature input of the cooling water. Exhaust gas temperature is this exhaust heat loss. So, it is also a sensible type of heat loss, and it is measured as mass of gases into specific heats of gases leaving the engine into temperature difference between ambient condition and the exhaust gas condition. We also done some exhaust gas analysis, we measured gases, 5 gas analyzer is used. With the help of 5 gas analyzer you can measure the different gases coming out from the engine, like NOx, hydrocarbon, carbon monoxide, carbon dioxide, oxygen, etc. Smoke density is measured to measure the smoke from the engine, it measures the opacity of the smoke. Now, come to the topic blow by measurement. What is a blow by measurement? You know that after a time at very high compression pressure, the combustion chamber, in the combustion chamber there are residual gases, and residual gases and air fuel mixture also. This is the cylinder part, and in the cylinder there are some cylinder liners, these are cylinder liners, this is the piston part, this is cross section of any piston, this is piston, and there in the piston there are some piston rings. So, at very high pressure there is a possibility that these combustion products as well as the fresh charge can leak from here. After a long run of the engine, these piston rings may get damaged. So, there may be some, or maybe if it is used at higher compression ratio also. So, the gases or the residual gases or the fresh charge may come out from the these space through the piston rings, and what it will do, they may, because if we see There are some lubricants, lubricating oils here. These are combustion products and the fresh charge also. So, these fresh charge as well as combustion products pass through this space and may get mixed with the lubricating oil at very high temperature. It damages the lubricating oil also, it contaminates the lubricating oil. So, blow by is the escape of unburned air fuel mixture and burnt gases from the combustion chamber. It passes the piston rings and into the crankcase. A result is the contamination of lubricating oil, and it is measured with the help of a sliding tube device. Here this is the sliding tube type A and B. So, A and B are sliding tube types. Tube B can be connected to flow meter or gas meter to find the rate of blow by. So, with the help of it we can measure how much amount is leaving from the combustion chamber. So, blow by is not desirable in case of SI or CI engine. Now, come to the testing of SI and CI engine. What do you mean by testing? Testing means if a manufacturer is predicting that this engine is of 5 HP, means 5 horsepower or 5 kilowatt power, it will predict 5 kilowatt power. So, we have to check that engine, either it will give you 5 kilowatt power at full load or not. So, that is called testing of SI or testing of CI engine. So, what are the parameters for testing? We have discussed, there is performance parameter like brake power, indicated power, its thermal efficiency, brake specific fuel consumption, exhaust gas temperature coming out from the engine. So, it is torque, these are the parameters. Engine may be constant speed type, engine may be variable speed type also. So, in constant speed type engine means we kept the RPM near about constant throughout the load condition. So, if we see if a constant, for example, I am taking a constant CI engine that running at a constant speed of an around 1500 RPM. So, the brake specific fuel consumption and at the brake power, the BSFC is like this. Similarly, the mechanical efficiency can be measured like this. This is for variable speed type of engine. Specific fuel consumption nature is like this. Indicated thermal efficiency, brake thermal efficiency, and this is for petrol engine. Similarly, for the diesel engine, the torque variation with respect to the RPM, the brake horsepower, brake mean effective pressure variation, specific fuel consumption. So, testing means either that engine follows the required behavior as declared by the manufacturer. So, we will do all these tests. Now, we will take a numerical problem. I am reading the problem. The air flow to a 4-cylinder 4-stroke petrol engine is measured by means of a 7.5 centimeter diameter sharp edged orifice. Coefficient of discharge is given to you. During a test on the engine, following data were recorded: bore 11 centimeter, stroke 13, engine speed, brake power, fuel consumption, calorific value, all are given to you. The pressure drop across the orifice 4.1 centimeter of water, atmospheric temperature and pressure is given to you. Calculate thermal efficiency on brake power basis, means brake thermal power, brake thermal efficiency. brake mean effective pressure, volumetric efficiency based on the free air conditions. So, we know that from the formula brake thermal efficiency is brake power upon mass flow rate of fuel into its calorific value. So, with the help of it, it is all the parameters given, it comes out 29.4%. Now, the brake mean effective pressure, it is brake power per cylinder, because it is a 4 cylinder engine. So, we will take brake power per cylinder upon swept volume LAN. So, 36 by 4 pi by 4 d square L and 2250 is RPM per unit time. So, it comes out 3.885 bar. Now, volumetric efficiency is measured volume of air inhaled upon swept volume. Volume of air inhaled is measured with the help of this formula CD into A orifice, we have already discussed it in air box method, under delta P rho air, where delta P is given in terms of water, rho GH we convert into rho GH, and rho air can be calculated P upon RT. P is atmospheric pressure, R is characteristic gas constant of air, into T in temperature Kelvin, which is given as 15 and 1.0. So, it comes out, rho air comes out here, and so air inhaled with the help of this formula, coefficient of discharge is given to you. So, it is comes out 0.0832 kg per second. Now, because you have to evaluate swept volume also. So, swept volume is number of cylinders, because there are 4 cylinders. So, total swept volume is equal to number of cylinder into pi by 4 d square L into the working cycle per second, because it is a 4 stroke engine. So, here we will take working cycle as n RPM by 2, RPM by 2. So, here RPM is given to you 2250, the working cycle, because it is 4 stroke, that is why we will take n by 2. Finally, we will get, if you put the values, you will get volumetric efficiency is equal to 0.898. So, today we have discussed about the testing and performance of any SI or CI engine, what are the parameters which are used to predict the behavior of any engine. We have also discussed the blow by measurement, and also we have done a numerical problem on that. So, this was all about for this lecture. Thank you so much.